Alright, so I'm going to go through and show you how I use the periodic table to determine the electron configuration for different atoms. And I'll give you a couple of brief examples and go through them. The first thing I'm going to do first, though, is remind you of the different blocks that there are. So remember, I'm not even going to write out all of the ones that we did in class. It's tedious, but it was necessary in order for you guys to really understand what was going on. So here, I'm slowly kind of struggling with my pen. I'm drawing the S block. Okay, so this is going to be the S block. In blue, I am drawing the P block. Okay, so that's P. The helium is actually part of S, so I'll include it so it doesn't feel all alone. And then the transition metals are actually going to be the D block. So in green, we've got D. Okay. And then I'm not even going to color them in because I'm struggling. But the bottom in beautiful orange will be F. Okay, a couple of things for you to remember as we're going through this. Each block represents an electron. And remember, we represent the electrons with the little superscript, which you'll see in a second. The other thing is that the F's, while the normal rows that we use are for our principal, represent our principal energy level. So first row, second row, third row, fourth row, etc., etc. The D's are funky. They start with a 3 instead of a 4. And the F's start with a 4 and a 5. And they literally go, as you can see with this periodic table, they go in right there. Okay? So if I were to be talking about Lu, I would go from here, from cesium, barium, I would go through this entire row of F's, and then I would go to Lu. Alright, so it's kind of funky. Your periodic table might look different from this. Honestly, we will very infrequently use the F's, so don't freak out too much about those. I just want you to get, in this at least, just a basic understanding of how to write the electron configuration. So the first one I'm going to write is for nitrogen. Okay, I'm going to just come up with a couple random ones. So I'm going to read it like a book in English, so I'm going to read across, starting at the top from left to right. So here I've got my 1s, and it's going to be 1s1 and 1s2. Instead of writing 1s1, 1s2, which would be really tedious, I'm just going to write 1s2. And the reason why I can do that is because if I write 1s2, I've implied I've already passed by the 1s1. So I'm just going to write 1s2. Then I'm going to write 2s2, because I include both of them. Okay. And I'm stopping at nitrogen, so I'm going to write 2p, 1, 2, 3. So if you notice, you really don't need that chart that we created in class. It's nice to begin with, but start being able to do this without that because you're just going to get the periodic table on a test. And if you try it with just a periodic table, you'll realize it's actually really easy to do. All right. Next one I'm going to do titanium. I'm going to do Ti. Okay. I'm going to start here at the top, end up down there. So it's going to be 1s2. Then 2s2. Then I want to include all of these guys, all 6 of these, so 2p6. Okay. Then 3s2. Okay. Then 3p6. Notice I'm still not including my d's yet. I haven't gotten there yet. 3p6. Then 4s2. And then finally, remember D's start with a 3, they're just weird like that. 1, 2, so 3d2. Okay? I'm not going to move on. I'm going to just stick with those 2 examples. I'll read out one more. It's just taking too long to actually write it all. I'll do germanium, GE, and then I'm going to call it a day. So to write the electron configuration of germanium, it would be 1s2, then 2s2, then 2p6, 3s2, 3p6, 4s2, 3d10, all of those, all 10 of them, and then 4, I go back to 4 now, 4p12. Okay? Now, the reason someone had said, why are we even learning this? What does this mean? What this tells us, for example, for nitrogen, it tells us that 2 of its electrons are in all likelihood going to be within a very tiny sphere close to the nucleus. Here's my nucleus, the dot in the center. Then it tells me that another 2 electrons are going to be within a little bit bigger of a sphere. And then it tells me that 3 of them are going to be within one of the 3 orbitals that P has. So it can be like this. It can be another one that kind of goes along into the page and out of the page, and then one that's vertical. So there are 3 orbitals for P. It's telling me that 3 of the electrons will be found, in all likelihood, in this area. It's really funky, but just knowing that the S is telling us that it's a sphere. The 1 tells us it's really small. If you get up to 4s, the 4 makes it a lot bigger of a sphere. But this is just telling us, in all likelihood, this is where we're going to find all of these different electrons and the number of electrons within that region. Instead of the typical Bohr model where it's perfect orbiting, we don't have that anymore, unfortunately. We've got these orbitals. So this is the electron configuration. Tomorrow, or our next class, we'll probably be talking about orbital diagrams, which will help us to even better understand this. But that's the very beginning intro into electron configuration.